In this example, we will determine if the given improper integral is convergent or divergent. Now, notice because of the wording, determine if it converges or diverges. We do not actually need to evaluate the integral. Instead, what we are going to do is apply the comparison test. In order to apply the comparison test, if we think the improper integral is going to diverge, what we would like to do is find a smaller function that has a divergent improper integral. Or if we think it converges, we want to find a bigger function that would be convergent. In this case, if we focus in on the integrand, e to the x over square root of x squared minus 1/2. Now the observation I would make is thinking about going from 1 to infinity, we're plugging in large values of x. The e to the x itself becomes very large, which isn't going to be a good thing in terms of enclosing a finite amount of area. Also, if you look at the square root of x squared in the denominator, that's going to end up behaving for large values of x like an x. And we've seen in terms of our p integrals that the integral of 1 over x from 1 to infinity is a divergent improper integral. So what I'm going to do is compare with something smaller. And I'm going to think about kind of two nice ways to get something smaller. So one way to get something smaller is to take the function that we have in the numerator and replace it with a smaller quantity. And if we think about the exponential function e to the x, something that it will always be larger than is 1. So I could simply say that 1 is less than or equal to e to the x, specifically on the interval here from 1 to infinity. Also, if I want to get something smaller, what I can do is make the denominator larger. And a very simple way to make the denominator larger is instead of having x squared minus 1/2, we are going to replace that with an x squared. So divide by something bigger gives you something smaller. And this is 1 over x, and both of these quantities are positive from 1 to infinity. And now we are in an ideal position to apply the comparison test. So to summarize this up, we can note that since the integral from 1 to infinity of 1 over x is divergent, it follows by the comparison test that the integral we are interested in is also divergent. And one important thing to keep in mind is, in order to maybe see this from a bigger picture perspective, think about it in terms of the geometric interpretation. On that interval from 1 to infinity, the function 1 over x does not enclose a finite amount of area. So if we look at a larger function on that same interval, it could also not enclose a finite amount of area, hence the improper integral will be divergent.